Okay, today we're going to look at section 3.5, talking about rational functions, and look at graphs, applications, and models. A rational function, say f of x, equal to p of x divided by q of x, where p of x and q of x are polynomials, and q of x does not equal 0. The domain of a rational function includes all real numbers except those that cause the denominator to equal 0. So, find the domain of the rational function. Give your answers in interval notation. So our denominator cannot equal 0. So x minus 7 cannot equal 0, which means that x cannot equal 7. So everything else is good. So we start out at negative infinity. We get to 7. 7 is not included. Then we start at 7 and we go to infinity. Again, the parentheses indicate it's not included. Okay, now we have x squared plus 10x plus 9, again, cannot equal 0. Well, this factors to x plus 9 times x plus 1. So x plus 9 cannot equal 0, or x plus 1 cannot equal 0. So x cannot equal negative 9, or x cannot equal negative 1. So again, starting at negative infinity, we come to negative 9. It's not included. We start at negative 9. We get to negative 1. Again, not included. And we start at negative 1 and we go to infinity. Interval notation, specifically asked for. If that's the case, make sure you do it. So, next thing we're going to talk about is an asymptote. They're important for graphing rational functions. They have horizontal, vertical, and slant asymptotes. These are horizontal, vertical, or diagonal lines that the graph approaches. The graph will never touch a vertical asymptote, but it can touch or cross horizontal or slant asymptotes. So finding a vertical asymptote is essentially a two-step process. Simplify if the numerator and denominator have a common factor. If there's a common factor, factor it out. Set the denominator equal to 0 and solve for x. So basically what we just did, we found the vertical asymptotes. Horizontal asymptotes gets a little trickier. So if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator equals the degree of the denominator, then the horizontal asymptote is the ratio of the leading coefficients. The third type of asymptote is called a slant or oblique asymptote. These occur when a polynomial in a number is a higher degree than the polynomial in the numerator is a higher degree than a polynomial in the denominator. To find the slant asymptote, we use long division or synthetic division, and the quotient will give the equation of the slant asymptote. So find the vertical and horizontal asymptotes of the rational function. Well, the vertical asymptote, we set x plus 2 equal to 0, x equals negative 2. Okay, going to the horizontal, numerator is less than the denominator, so it is simply y equals 0. That's the horizontal. Okay, here, my vertical asymptotes, x equals negative 7, x equals positive 7. horizontal. This has but the numerator or the denominator has a degree of 2, numerator has a degree of 1. Degree of numerator less than degree of denominator. So again, we have y equals 0. Okay, again here, this will factor into x plus 3, x minus 1. So the verticals are x equals -3, x equals 1. Horizontal, I have a degree of 2, a degree of 1. Y equals 0. Okay, looking here, this will factor x plus 3, x minus 2. So my verticals again are x equals -3 and x equals 2. My horizontal, I have the same degree. So understood 1, understood 1. Y equals 1 divided by 1, which is 1. Y equals 1. Okay, now we find the oblique asymptote. Doesn't care about the others, just wants the oblique. So do our division. X plus 5 goes into x squared minus 6x plus 7. So x goes into x squared. We have x. X gives me x squared plus 5x. Subtracting all this, now I have negative 11x plus 7. So minus 11. And I get negative 11x minus 55. Subtracting will give me 62 as the remainder. But this is all we want. So your oblique, simply y equals x minus 11, which will be a slanted line. Another important feature when graphing rational functions are the x and y intercepts. Finding an x and y intercept. The x-intercept, simplify. The numerator and denominator have a common factor. Set the numerator to 0 and solve for x. Y-intercept, just let x equal 0. So I don't see any simplification. So essentially, if we let 4x minus 8 equals 0, 4x equals 8, x equals 2. That is our x-intercept. 2, 0. We set the numerator equal to 0. To find the y-intercept, we simply let x equal 0. So I have 4 times 0 minus 8 over 0 plus 8, which is negative 8 over 8, which is negative 1. So we have 0, negative 1. That's simple. Okay, same deal here. Finding x, y intercepts. First, we'll find the x-intercept by setting x squared plus 8x plus 7 equal to 0. This will factor x plus 7 times x plus 1. So x plus 7 equals 0, or x plus 1 equals 0, x equals negative 7, x equals negative 1. Have negative 7, 0, and negative 1, 0. Okay, now to find the y-intercept, let x equal 0. F of 0, we have 0 plus 0 plus 7 over 0 plus 0 minus 21. 7 over negative 21 equals negative 1/3. So we have 0, negative 1/3. Now we put it all together. Graphing rational functions. First, draw the horizontal and vertical asymptotes. plot the intercepts and plot at least 2 points on each part of the graph. So, graph the following rational function. So first of all, let's find our asymptotes. So we have negative x plus 3 equals 0, negative x equals negative 3, x equals 3. So that is a vertical asymptote. Now y, we have first degree, so it's simply y equals 0. Now finding the intercepts. Set negative 2x plus 4 equal to 0. Negative 2x equals negative 4, x equals 2. I have a y-intercept here. Or an x-intercept there. Finding a y-intercept, we let x equal 0. So f of 0 is equal to 0 plus 4 over 0 plus 3, which is 4/3, which is right about here. So I have 2 points on this side. What's going to happen here? It's probably going to go something like this. And continue like that. Okay? So now let's find 4 and 5. Let's find f of 4. Negative 2 times 4 plus 4 over negative 4 plus 3. What's this? Negative 8 plus 4 is negative 4 over negative 1, 4. So we have 4, 4. And then let's find f of 5. Negative 2 times 5 plus 4 over negative of 5 plus 3. This is negative 10 plus 4, which is negative 6 over negative 2, which is 3. Now it looks like we're going something like this. And that's our basic graph. Okay. Again, we have same degree, which means y equals 0 is our horizontal asymptote. We have x squared minus 4. X squared equals 4. X equals plus or minus 2 are our vertical asymptotes. Find the x-intercept by setting x squared plus x minus 12 equal to 0. That's x plus 4 times x minus 3, 0. So x equals negative 4 or x equals 3. There's one there. There's one there. So the horizontal asymptote doesn't cross the vertical. Okay, now we need to find the y-intercept by setting x equals 0. Finding f of 0, get 0 plus 0 minus 12 over 0 minus 4, which is 3. So we need to find another value here. So what? Let's look at negative 3. F of negative 3, what's that? Negative 3 squared is 9 minus 3 minus 12 over 9 minus 4, which is negative 6 over 5. So that would be here. So looking at this, it's going to go like that. And it's going to go off like that. Okay, let's go ahead and look at 4 here. F of 4 equals 16 plus 4 minus 12 over 16 minus 4, which is 8 over 12, or 3/4. Now that is here. Now we're looking at something like this. Now let's find the middle. Let's try -1 and 1. So let's try -1 first. And we have f of -1 equals 1 minus 1 minus 12 over 1 minus 4. This is -12 over -3, which is 4. So at -1, we're at 4. At +1, f of 1, we get 1 plus 1 minus 12 over 1 minus 3. That's the same thing. Nope, this is 10. -10 over -2, which gives me 5. So we're looking at something like this. And that is it. Doing this by hand, that's the best that we can do. One more to look at. Again, degree of the numerator and the degree of the denominator are the same. So that gives us y equals 0. Set the denominator equal to 0. X squared plus 4x minus 5 equals 0. This is x squared plus, or x plus 5 plus 5 times x minus 1. So x equals -5, or x equals 1. So I have one at -5 here, and I have one at 1. Okay. Now looking for my intercepts. If I let x equals 0, f of 0, 0 plus 0 minus 8 over 0 plus 0 minus 5, 8/5. So if x is 0, we get to 8/5, which is about here. Okay. Then we set our numerator. Yep, let's do this over here. Numerator equal to 0. This factors to x plus 4, x minus 2. So x equals -4, x equals 2. So I have one here. I have one here. Okay, so we need another point. Let's look at, here we need another point. Let's try 4, see what happens. So f of 4, 16 plus 8 minus 8 over 16 plus 16 minus 5. This is 16 over 27. That's nasty. That's a little more than a half. This is here. So I'm looking at something like this. So I have these 2 points. Let's go ahead and look at -2 here. F of -2. Well, that's 4 minus 8 over 4 minus 8 minus 5. -8 over -9. So at -2, that's just shy of 1. Here. So I'm looking at something along the lines of a parabola in the middle. So now let's look at f of -6. So I have 36 minus 12 minus 8 over 36 minus 24 minus 5. 16, 7, a little more than 2. That would be about here. And then let's look at -8. F of -8 equals 64 minus 16 minus 8 over 64 minus 32 minus 5. So this would be 40 over 27. Which is a little less than 2. So we're looking at something like this. That's how these are done. They can be kind of messy. Just takes practice. That's all for this section. That's it for chapter 3 as well. Have a good day, and I will see you next time.